Who are you texting?
Nobody, I'm trying to make it Twitter.
You go running? I saw you doing the weights. You like that?
Yeah,
Seems to help a little bit, doesn't it?
it does.
We actually do have to live in the city. Our backyard is actually really nice.
We are blessed.
Cujo just didn't mess it up all the time. That Errol's like saying, "Hey, let's go." Oh man, I forgot. I'm on live. All right. Good morning, guys. Good morning, Abby, Caitlin, Kelsey, Bernice, Kristen, Lucy, Dom, Elena, Maddie, Sebastian. Good morning. I hope you guys are having a good morning. Know we had a different schedule today than normal, but glad you guys are all here to make it. Let's first start with questions over 5.5 homework. Elena says 10. Okay, so with number 10, all right, here's what it's saying to do. G compose with H. And Abby, I'll go to 6 too here in a second. So that means we're putting H into G. And you're just solving it in terms of N. So here's what that looks like. We're literally putting H into both ends. And again, we didn't see this on the notes, but if you recalled in the notes that I said, hey, if you have more than one end, you got to plug it into both of them. Okay. So in this case, we're going to have this 3n plus 4 cubed minus 5 times 3n plus 4 squared. All right. So from here, remember this whole 3n plus 4 cubed. So let's take this over here to the side and say, let's first do this 3n plus 4 times 3n plus 4. Let's square it first, okay, to get a trinomial. So first, 9n squared, outside 12n, inside 12n, and last 16. So that would be 9n squared plus 24n plus 16. Now we have to multiply this trinomial times another 3n plus 4. So 3n and plus 4 here. And if you remember, that's where we can do the whole rows and column type method. Okay? So here, 3n times 9n squared would be 27n cubed. 24 times 3 would be 72n. 16 times 3 would be 48n. And I'm sorry, that's 72n squared. 4 times 9 would be 36n squared. 24n times 4 would be 96n. And 16 times 4 is 64. Okay. So that will take us to 27n cubed. 36 plus 72 which should be 108n squared. 96n and 48 should be plus 144n plus 64. Sorry, that gets really crazy right there. So I'm just going to rewrite here. 27n cubed plus 108n squared plus 144n plus 64. Good morning, Christina. And all of that is saying minus whatever we get here. So this looks like this. 5 times 3n plus 4 times 3n plus 4. Those of you that already worked this, of course I haven't worked this. Does it look right thus far for does this look right for what you got? Yes, no, or I did it a totally different way? Okay, cool. All right, just making sure. Here we can distribute a couple different things. You can FOIL it first, which I think may be a little bit easier if you FOIL first before you multiply by 5. Get the trinomial and then multiply everything times 5. Which, of course, you could just put the 5 into one of these, but I think it'd be easier like this. So 5 times, and then that would be 9n squared. Then outside would be, we've already kind of worked it up here, so plus 24n and then plus 16. Yeah, correct. It would be -5. You're right. Thank you. So then -5 times 9 squared would be -45n squared. And then -5 times 24 would be -120n. And then -5 times 16 would be -90. So, of course, we know we attach the negative with the 5, so it's -45n squared minus 120n minus 90. So the 27n cubed is the only 27n cubed, so that's staying. 108 minus 45 would be 63n squared. 144n minus 120n would be positive 24n. Oh, yeah, that would be 80. Sorry. My bad. Good catch. And then 64 minus 80 would be minus 16. I'm assuming that's correct. Is that what the answer key has? Okay. You good on number 10, Elena? That cool? Okay. Abby, you said 6. So 6. Here we go with number 6. So with 6, it says f times g of -3. So here's what we have here. We have f is -3n plus 3 times -2n squared minus n. Now, a couple of options. We can factor this, or excuse me, not factor, we can FOIL this, but we're looking for -3, so we could just plug it in. What do y'all want to do? FOIL or plug in? Okay, Bernice says plug in. So let's plug it in because that's what Bernice said. -3 times -3 plus 3, -2 times -3 squared minus a -3. So you got to make sure you plug it in correctly, okay? So -3 times -3 would be positive 9 plus 3. We know that's going to take us to 12. Over here, -2 times -3 squared would be 9. And -1 times, or minus would be a plus, or -1 times -3 is positive 3. That would be -18 plus 3. And then I have 12 times -15. And 12 times -15 would be -180. Cool. Very good, Abby. Any other questions on 5.5 homework? Seeing no other questions, let's go to 5.6 notes. Give me a thumbs up once you have 5.6 notes ready. Got Bernice, got Elena. Caitlin's good, Maddie's good, Dom's good, Christine's good, Kristen's good. Kelsey's good. All right, so let's jump into this. Lesson 5.6 notes, inverse relations and functions. So, when we're dealing with inverse relations and functions, okay, we are talking about an inverse relation. A relation is just an XY chart that we're dealing with. So like a relation, an example of a relation would be an XY chart like this. -2, 1. -1, 4. 0, 3. And 1, 1. So a relation is a function, okay? This still is a function. Each input has exactly one output. No x's are repeating here, right? So it's still a function, all right? So it's still a function. Now this y repeats here, but that's okay because you can think of like x squared. X squared is a function. It passes the vertical line test and it has more than one y. For instance, 1, 1 and -1, 1. But there's no repeating x's. So that means that this relation here, it is a function. Okay. Now where we're going today is an inverse relation. If you had to define inverse, how would you define it? Type it into the chat box. If you had to define inverse, how would you define it? Type it into the, just a one-word definition of inverse. What would you say? Yeah, and we're all kind of on the same page here. Opposite. Okay, so inverse, and again, if you hear me talk when I say, I like to use, good vocabulary in math. So we use inverse operations. What's the inverse operation of this, or what's the inverse operation of that? And sometimes you guys get stuck in that elementary trap to say, oh, do the opposite. So again, that goes to say that inverse and opposite are the same thing. So with them being the same thing, so I'm saying let's do the opposite of this. So what do you think that means in regards to, so what would be an inverse relation? If inverse means opposite and relation is just a XY chart, what do you think, what does that mean in terms of a inverse relation? Just type that into the chat box. What do you think that means? What is inverse relation then? What is the opposite? Good, Christina. We're just going to change or flip the x, y, the x and y's of the relation. So now my x will be 1 and my y will be -2. No, Caitlin. And then, so again, you are just changing x and y. Changing x and y. So then here, that would be 4 and -1. Here, that would be 3 and 0. Here, that would be 1 and 1. And that's what an inverse relation is. And relation and function, kind of the same word, guys. Okay, yeah, so very good. Maddie points out that, hey, there's 2 1s here now. And exactly right. So this would, so while the relation, the original function or relation is a function, this is not a function. This over here is a function. No x repeats. But over here, this would not be a function. All right. So define, if we were to define an inverse relation or function, same thing here. An inverse relation / function is formed when the roles of the independent, this is textbook definition, of the independent is always the x value. When the x is formed when the rows of the independent variable, the independent and dependent is always the y variables are reversed. An inverse function is written like this. Give me thumbs up if you're kind of following with me today. Basically, all that just simply means this. Switch X and Y. Switch X and Y, and you have an inverse. Okay. So let's jump down to the bottom here. Says for number 1, find the inverse of each function, then graph the function and its inverse. So first step we need to do is find the inverse. Then we need to graph the function and its inverse. All right. Should be pretty simple. So first step is to find the function. Or no, we have the function. We need to find the inverse function. So if the, and I'm going to come down here just a little bit. So if my function is g of x is equal to 5 plus 7/5 x, then my inverse function, okay, my g of -1 of x would look like this, okay? Now keep in mind that this right here is the same thing as y. Okay, keep in mind that g of x and y are the same thing. Now, so my inverse, so this is my inverse. My inverse function would look like this. I am literally going to switch the x and the y. I'm changing them out. So now it looks like this. And actually, let me write that out like this so you see it. Y plus 7/5 x. That's what we're looking at right now. So then my inverse would look like this. X equals 5 plus 7/5 y. I am literally switching the x and the y. So your first step to find an inverse, first step, switch x and y. Your second step, once you've switched them, so this is first step right here. Once you've switched them, then you solve for y. So from right here, we're now going to solve for y. Give me thumbs up if you're with me on this first step, switching x and y. Give me thumbs up, smiley face. Let me know you're still alive. You're not passed out on your laptop. Okay, cool. So you're all with me. All right, very good. So now let's solve for this y. So basically what I'm saying is we want to isolate this y now. So switch them and then isolate the y. So first step, you got to get everything away from the y. So let's subtract 5 from both sides. Cancels. I get x minus 5 is equal, and actually, I don't know why I put those parentheses around there. Don't worry about those parentheses. Is equal to 7/5y. All right. Now from there, I would divide both sides by 7/5 in order to isolate y. So that cancels there, and I'm left with y is equal to. Now, some of you guys can do this stuff in your head. You can do some mental math right here. And the more we do this, the better you're going to get at it. But let's just take it to the side right now and say x over 7/5. So most of you guys should remember that only thing we're going to do here, think about it, write x as a fraction. Think about it as a horizontal problem instead of a vertical. X over 1 divided by 7 over 5. And then I think you all call it keep, change, flip. We called it, we called it keep, change, flip. Y'all say, no, y'all call it keep, change, flip. We called it KFC, keep, flip, change, Kentucky Fried Chicken. So x over 1 times 5 over 7. So that would look like this. 5 over 7x. 5 times x is 5x over 7. And then I can just write the x to the side. That's going to make some sense when we're going to have to graph it here in a second. And then same thing with this negative 5. I would say negative 5 over 1 divided by 7 over 5. And I would get negative 5 over 1 times 5 over 7, which will take me to negative 25 over 7. So minus 25 over 7. So technically speaking here, my g, my inverse of x, is equal to 5 over 7 x minus 25 over 7. Okay, so now I have my inverse, right? I have my inverse now. So let's come up here. So my g of x, now I'm going to rewrite my g of x. I'm going to rewrite my g of x in y equals mx plus b form. So that would be 7 over 5x plus 5. And then my inverse is 5/7 x minus 25 over 7. Okay. Now we are going to graph those. Okay. So we're going to graph these two. And in graphing these two, this goes back to like algebra 1. Okay. So graphing these. So let's graph the first one. So the y-intercept is 5. So I'm going to put a point at 5. And then my slope is up 7, right 5. I cannot go up 7 and right 5 because I'll be off the graph. So I'll go the opposite direction. Go down 7 and left 5. 1, 2, 3, 4, 5, 6, 7, left 5. 1, 2, 3, 4, 5. Now, because I'm kind of a stickler, I need to actually find a straight edge real quick somewhere in my house. So let me get a straight edge real quick, and you can get yours out as well. Give me like 30 seconds. All right, I think I found one. I think this should work. So look in here. So it should be looking something like that. All right. Now let's go. I'm going to use a different color here, and I'm going to graph this one. Now, you may be saying, well, this is pretty insane because negative 25 over 7. Well, think that would be like 3 point something as a decimal. If you type it in your calculator, if you type negative 25 divided by 7, it's about it's negative 3.5. Okay, so that's our y-intercept. So we're going to place that point at negative 3.5, which would be down here. And then I'm going to follow this. Go up 5 from there and write 7. Up 5. 1, 2, 3, 4, 5. Oh, sorry. 1, 2, 3, 4, 5. And then write 7. 1, 2, 3, 4, 5, 6, 7. Off the graph just a little bit, but not terrible. I take my straight edge, line them up. I draw all the way through the graph. I have my inverse. I found my inverse, and then I graph my function. Questions on number 1? No questions, give me thumbs up if you're kind of seeing what's happening here. It's the first one, so don't stress out too much. Shh, landed. Sorry. All right. So, looking at number 2. All right. So, first step here, I need to find the inverse. Okay. So, I look at my g of x. So, g of x is equal. Now, up there it's saying negative 3x. It looks like this, negative 3x plus 5 over 7. But I can write that like this, so it makes it a little bit easier for me to see the graph. Y equals negative 3 over 7x plus 5 over 7. Sorry, my dog got a toy. All right, sorry about that. So I can just write each one of those over 7. Now, my dog has this pig from Walmart, and that thing is absolutely insane. And I promise you, he treats it like it's his own baby. Like no one can touch it. He's real possessive about it. So that's not me breathing hard. So going now, let's go to the inverse. Let's go to g of x. G to the negative 1 of x. So that would be x is equal to negative 3 over 7y plus 5 over 7. Okay? So now, first step, switch x and y. Second step, solve for y. So I'm going to subtract 5/7 from both sides and get x minus 5/7 is equal to negative 3/7y. Now, some of you may be saying, or actually, let's just work this one like this. So let's divide both sides by negative 3/7. And we got to do everything divided by negative 3/7. That cancels on that side. And I'm just going to go ahead and move y on this side. Y is equal to, over here, that would look like this. X over 1 divided by negative 3/7. So that's x over 1 times negative 7/3. And you should get negative 7/3x. And then likewise, this one, negative 5/7 divided by negative 3/7. So we say negative 5/7 times negative, flip it, negative 7/3. The 7s will cancel. A negative divided by, or a negative times a negative is a positive, so it should be plus 5/3. So that leads me to my inverse of the inverse of x is equal to negative 7/3x plus 5/3. I'm going to go back to my top now, go back up here to the top. And I'm going to say my g of x, I'm going to rewrite it so I can, a little bit easier to see the graph, is equal to negative 3/7x plus 5/7. Sorry. And then my inverse of x is equal to negative 7/3 x plus 5/3. Some of you are going to kind of catch some, oh, I can just do this each time, or I can do that each time. Some of you are going to catch that. I'm just going to kind of keep the same procedure, not really including any shortcuts. But if you look at the slope of this and the inverse, obviously it's just flip. If you look at the slope over here, it's obviously just flip. Okay. You may develop those shortcuts, but I'll just teach you the standard method. It's just one little division problem that shows you that. So it's not like you're going over a mountain to find it. So let's graph 5/7. Now 5/7 is not quite 1. Okay. So put a point at not quite 1. That's my y-intercept, right? And then I'm going to go down 3 and right 7. So down 3 from here. 1, 2, 3, and then right 7. 1, 2, 3, 4, 5, 6, 7. And then I could go up 3 and left 7. 1, 2, 3, and left 7. 1, 2, 3, 4, 5, 6, 7. Again, the more points I have, the more accurate my line will be. I then graph that line. Looking like that. Okay. And then I go to my other one. Now 5/3 is almost 2. It's like 1 2/3 actually. So I'm going to put a point at 1 2/3, which is just past this, like right here. And then I'm going to go down 7 and right 3. Down 7, 1, 2, 3, 4, 5, 6, 7, and right 3. 1, 2, 3. Okay. And we graph from there. Should be looking something like that. Now, here's my question to you guys. Does anyone see anything that both graphs kind of have in common? And I'll give you just a little bit of a hint. It has to do with reflection. Sorry, yeah, I had my mic off. I'm sorry. So, um, so my question was, looking at this right here, this line right here is being reflected over this line, and as well as notice here, this right here, it's a perfect reflection across that line. Over here, here's our original, and it's just been flipped over that line. So this way goes that way. It's been reflected across there. Okay. Good. They're equal distance from not necessarily the center, but what would this line right here be, guys? Somebody type it into the chat box. What would this line right here be? Bisector. No, think in terms of y equals mx plus b. What would that line be? Y equals mx plus b. What's my y-intercept? What's my slope? Very good. Just x, right? Slope is 1 over 1. My y-intercept is 0. So this line right here is actually y equals x. Y equals x. So this is a good way for you to check always check your graph. Does it reflect y equals x? So let's add a little note down here and say this. The graph, we'll put a little star here. The graph of an inverse is the reflection of the original function across the line y equals x. Okay, so the graph of an inverse is the reflection of the original function across the line y equals x. All right. So if you ever want to check, oh man, is my graph of my inverse correct? Just draw a y equals x line and say, does it look like a reflection? Now, the best way to always determine if something is a reflection is to turn your line of reflection vertical. So like turn your paper to where your line of reflection is vertical. Okay. And then that's a little bit easier to see the reflection there. Okay. And then same thing over here. Turn like this one for number 2 here. Turn that line of reflection vertical and you should see the reflection a little bit better. Okay. All right. Let's go to the backside. 3 problems and we're done, guys. Okay. So looking at number 3. It says, find the inverse of each function, then graph the function and its inverse. So same type problem, dealing with a little bit more different type equations here. So here we go. Looking at number 3. Number 3 is g of x equals the fifth root of x minus 2. So I'm going to copy that down here. Say g of x is equal to the fifth root of x minus 2. And I can say y equals the fifth root of x minus 2. So just change that g of x to y. And then from here, I'm just going to switch it. So x is equal to the fifth root of y minus 2. So that's our first step to find an inverse function. So inverse function, switch x and y, and then let's solve from y from there. So that would look like this. Add 2 to both sides, and I get x plus 2 is equal to the fifth root of y. Now, in order to isolate y here, hey, give me 1 second, guys. Sorry, I had to take a phone call real quick. All right, so the only way to isolate y right here is to take the fifth root of both sides. So then the fifth root and the 5 cancel, and I'm left with y equals x plus 2 to the 5th power. Now, I know a lot of you are thinking, oh my goodness, do we have to do the triangle? The triangle that we did in class to do x plus 2 to the 5th, and we actually don't have to. We actually know how to, we can solve that. Or we can graph that without, getting it into a polynomial. Okay, so this is my inverse function. So the inverse of x is equal to x plus 2 to the 5th power. So I'm going to come up here and write it right next to this one. So g, the inverse of x is equal to x plus 2 to the 5th power. Okay, so now let's graph both of these. Now, again, you may be saying, well, what does this have to do with, everything we've been doing? And it kind of comes back to this right here, because a lot of your inverses will be something like x to the 1/5 or the fifth root of x, which is that rational exponent that we've been dealing with in chapter 5 so far. So looking at this, okay, looking at this right here, how would I graph this? Someone type into the chat box what I'm going to do first here. What am I going to do? What's that -2 mean? Down 2. Very good, Maddie. So go down 2. Abby, can you see now? Sorry, I just saw that. Can you see now? Go down 2. Okay. So that takes care of that. Now, coming back over here. Okay. Now this is lesson 5.3 notes. Coming back over here. Remember when we had a cube of x? It goes up 1, right 1, and then over. Okay. Same thing here. All right. Same thing there. So it's going to be the same thing. We went down 2, so we've taken care of the down 2. And then now, what's the fifth root of 1? It would still be 1. So I'm going to go up 1 and right 1 and go down 1 and left 1. So I'm still doing that. Now, the next perfect fifth root would be the fifth root of 32, and that is 2. All right. So the next root you would have to do is you would go from here. You would go up 2 and go right 32. So we're going to assume that go up 2 and then right 32 is way over here. So we know it's going to have this general shape like this, guys. Going that way. Same thing here, going that way. So kind of like the same shape as x cubed, but instead of going, the next one with cube would be up 2, right 8. This is going to be up 2 and right 32. All right. Now let's graph x plus 2 to the 5th power. Now, what does that plus 2 on the inside of x to the 5th do? What's that plus 2 mean? Go where? Go left 2. Good, good. There we go. So let's go left 2. I'm right here. And then that takes care of the plus 2 there. Now, most of you know that x cubed does this right here. Well, x to the 5th power is going to do practically the same thing. All right. So if you plug a 1 in there, you get x 1 to the 5th power is 1. So you still go right 1 and up 1, and then down 1 and left 1 if you plug in a negative 1. But just like this, if you say 2, you put a 2 in there. 2 to the 5th power is 32. So you'd have to go right 2 and all the way up to 32. So it's doing this right here, guys. It's increasing, increasing, increasing like that. Same thing here. It's going down and increasing like really fast to get down there to the 32. So I have this is g of x, and I have this as g, the inverse of g of x. Now my question is this is looking really funky, but here's my question. Do I have the correct inverse? How can I check that? I need to graph what line? Y equals what? Very good, Maddie. Y equals x. So graph y equals x and see, is it truly reflecting that y equals x line? Now the best way for you to see a y, to see if it's a true reflection, is to turn your turn that line of reflection vertical. So if I'm going to turn this line of reflection to where it's up and down vertical, then I can see that that's more of a true reflection of what I have here. Okay. How we feel about this? Good? Give me thumbs up, smiley faces, something, or if you have a question, ask a question now. Cool, cool. I figured you'd have a comment, Christina. Okay, most of you looking pretty good. So let's jump to 4. So number 4. Okay, so looking at number 4. So first step is we got to go find the inverse. So let's go find the inverse. I have g of x. G of x is equal to 1 plus x to the 5th, which we know that's just y equals 1 plus x to the 5th. So the inverse of that, g to the negative 1 of x, that would simply be x equals 1 plus y to the 5th power. Now from here, you want to isolate y. So let's subtract 1 from both sides. I get x minus 1. And then that's equal to the y to the 5th power. And then I'm going to take the 5th root of both sides. So then therefore y is equal to the 5th root of x minus 1. So I have g of x as 1 plus x to the 5th power. And my g prime of x, or not g prime, sorry, calculus kicking in, the inverse of g of x. And that's how we would say that. The inverse of g of x is equal to the 5th root of x minus 1. So now let's graph. So when I graph this, first one, what does that 1 on the outside do? What does that plus 1 do? What does that tell us to do? Up 1. Very good. Go up 1. And then we know that x to the 5th is right 1, up 1, down 1, left 1. And then the next one would be right 2, up 32. So we know it's increasing here. And same thing down here. It's going down and it's increasing fast there. So that's x to the 5th power. I then go to my inverse. What does the minus 1 on the inside of the square root do? That goes to the what? To the right one? All right, very good, Christina. Goes to the right one. And then again, the 5th, how do I graph the 5th root of x? Again, it's just like x cubed. It's the snake, but it's sideways. So go up, right 1, up 1, left 1, down 1. I would have to go up 2 and right 32, which I can't do that. So I'm just going to graph that looking like this and graph that one looking like this. Okay. So then from there, I can draw that y equals x line. And I can turn my paper sideways to make that line of reflection go vertical. And I can see that I have reflection across y equals x. Give me thumbs up. Make sure you're still with me. Just one more problem, then we're done today, guys. Thumbs up. You're good. Kelsey, Bernice, Kristen, Dom, Abby, good. I think some people may be a little bit behind. Good, Caitlin. Good, Maddie. Good, Lucy. Christina's still kid in the candy store. Just saying, wow, it's an art collection. Wow. Okay. I assume that's most people here with us. Going to number 5. Okay. So looking at number 5, here we go. Find our inverse. Well, we got g of x is equal to 3 plus x minus 2 to the 5th power. Don't make me start impersonating people on here, Abby, because you want to hear some impersonations. Y'all know I can make it happen. Y equals, I don't know if I ever told you guys about my Barack Obama impersonation, but I thought I really had a good Barack Obama going. But then my wife literally flamed me over it. So, I mean, she didn't just she lit my whole body on fire when she made fun of me. So, um, now if we look at the inverse of that, if we look at G, the inverse of G of X, that's just going to be, that's exactly right, Maddie. If you can be an auctioneer, you can basically do anything you want. X equals 3 plus y minus 2. But here's the thing. Here's the thing. If you can impersonate people, I mean, you're just a legend anywhere you go, basically. I've tried. See, and it's hard when you're put on the queue. I'm not a jukebox. I got to get prepared for it. I got to get ready. I just can't go into my Morgan Freeman voice. Yeah, you see, it's harder. You just can't jump right into stuff. Okay, it's a little bit hard. Some of them are a little bit easier than others. You know, gee, Scoops, what are we gonna do? You know, those are a little bit easier. I don't know, Shaggy. What are we gonna do? You know, some of those are a little bit different. You know, some of them are hard. But again, I'm going like right off the queue on a YouTube live. So I am like basically setting you guys up to literally light me on fire, just as my wife did. But I feel like I had a really good Barack Obama, but my wife flamed me for it. My country accent kind of gets in the way. It kind of gets in the way of many things. So, and that was one of my big things with Barack Obama, because then I listened to myself, like I recorded myself doing my best Barack Obama, and it just I just heard too much country accent in it. Like when I go back and like listen to these YouTube live videos, I'm just like, man, I sound like country. So I got to get better. Maybe since I'm quarantined, maybe I could get better at my Barack Obama. But I don't know. Okay, so last problem, and you guys are getting me off topic. So I switch the x and y. I now say x minus 3 is equal to y minus 2 to the 5th power. So do the 5th power of that. That cancels. And then I have the 5th root of x minus 3 equals y minus 2. So then the 5th root of x minus 3 and then plus 2 is equal to y. So my memory palace, I actually haven't, I can still do all the hearts, but I haven't moved on from the hearts yet. And what it is I read like I read about that in a book, but then I keep reading other books. So then my mind kind of changes to something else. But now would be a perfect time to do the memory palace. I don't know. Who knows? I may do it. This depends on how much we get out of school. So I'm telling you guys, this is much harder than being in school, working every day. This is worse for teachers. Well, for me, I'm doing more work now than what I normally do. So I would much rather be in school doing this than not. And then I don't know if Disney's going to reopen or anything like that. So then I may not be able to go on vacation. So, folks, we're looking at oh gosh, I can't even think about it. I know, and it's funny because it's like, some people are like, man, I'm going to start doing all this stuff, and I'm going to do that, and I'm going to do this, and I'm going to do that, and it's just like, dude, I'm out here making YouTube videos, so it's hard. It's hard for it's hard for me to kind of find a good routine just because I have been so busy. So because I have this class, I have regular algebra, I have AP Calc, I have Trig, so it's not. I don't know. It's a little bit different. So this is more work for me. All right. So now that we've kind of make sure I had that. So again, took the fifth root, then added 2 and got y equals. A family vlogger. Yeah, that'd be awesome. My son would love it. Landon would absolutely love to vlog. He's always like saying, hey, let's make a video. Let's make a video. If it gets, I can tell you this, if we don't go back soon, I may have to start a video log just so I don't drive myself insane. And then who knows, I may get a reality show from like TLC, IPOX Quarantine. You never know. All right, so now let's graph this right here. So I go up 3 and right 2. Up 3, right 2. And then x to the 5th, we know it's going to do that number right there. Left 1, down 1. And then we know it's going to go down in a quick hurry. Looking something like that. And then over here, I need to go up 2 and go right 3. 1, 2, 3. And then I just need to make that right there and go like that. And then, oh boy, got a little off there. Looking something like that. I draw my, you don't have to draw this y equals x line. It just kind of goes to kind of help you to make sure, okay, I got a reflection across the y. Okay. All right. So now we're kind of done with that, but let's just talk about something else that sometimes you can see within this. And that's like, what if we had y equals, what if we had like y equals x squared? Okay. Now we all know that y equals x squared looks like this. We know y squared looks like this right here. Okay. But the question is, what does its inverse look like? Okay. So its inverse would just be switching these. X equals y squared. So do the square root of both sides. And that would be y equals plus or minus radical x. Now, let's first do plus x. Do plus x first. So this is my inverse of this. Okay, so this is actually, y negative 1. So if you remember, square root of x looks like this: 0, 0, 1, 1, 2, 4, 2. So it looks like this. And then technically speaking, the negative portion of radical x would be like when x is 1, square root of 1 is 1, but then you got the negative on the outside, so it'd be negative 1. So it looks like this. And then you plug in a 4, square root of 4 is 2, but then you have the negative on the outside, so negative 2. So it'd actually be looking something like this. And then keep in mind that still, does this satisfy the whole y equals x thing? Yes, it does. Okay, so that's a reflection across that. All right. But what I wanted to point out to you, okay, was this right here. Where I really wanted to go with this was this. How do we know if something is a function? How do we know if something is a function based on the graph? How do we know something is a function based on the graph? What test is it? Yeah, vertical line test. So vertical line test will tell us if this, okay, yeah, pencil test, vertical line test, whatever. That's fine, Abby. Pencil test. Most people know it as a pencil test. So we drop our pencil down and we go across x squared and we determine if it passes that. As long as it doesn't touch any parts, we're good. So we know that x squared is a function. It passes the vertical line test. All right. But I think someone mentioned something in the chat at the beginning. If we look back up here, somebody said, like, oh, but wouldn't that make that not a function? Yes, and we said yes to that because now we have two x's there. So on a function, we say if any x repeats, it's not a function. But how could I look at a function like this and know if its inverse is a function? How do I look like at a relation like this or a function, just looking at the function, not looking at all that, but how could I look at just the function and say, all right, I know this is a function because no x repeats, but how do I know? How could I look at this and know whether the inverse is a function or not? Someone type that into the chat box. Very good, Christina. Let's see if any of the y repeats. Okay. Now, seeing if any of the y repeats. Good, Christina. Good, Caitlin. So if any y repeats, then the inverse is not a function because we know these are going to change. So looking at this, okay, -2, -1, 0, 1, we said if any x repeats, it's not a function. But if we look at the y's and say if any y's repeat, the inverse is not a function. So if I go back here over here to x squared, if I go back here to my graph here, think about if I just, let me draw another graph of x squared. Okay, so my question to you is this. Does it pass the vertical line test? The vertical line test. Someone type that in. Yes or no. Does this pass the vertical line test? Good. Yes, it does. Okay. Now, the question is, where does that vertical line test come from? Well, that vertical line test came from this. If any x repeats, it's not going to be a function. So if an x repeated here, if an x was the same, it wouldn't pass the vertical line test. Is that correct? So if an x repeated here, somewhere like if another x was like right here, then that vertical line test comes from that. So if an x repeated, it wouldn't pass the vertical line test. So like for instance, and I know I'm getting a little crazy here with all this. For instance, if I had this graph right here and I had something that did, it went here and then back here. Notice this x value 1 is repeating. So it does not pass that vertical line test. So that's not a function. But over here, obviously, no x repeated, so it passed. So if the vertical line test will tell me no x repeats, then what test could I do to determine if the inverse of this function is a function? Good, Christina. Good, Caitlin. The horizontal line test. Okay? So, vertical line test tells me if the function is a function. Okay? But a horizontal line test, drop that pencil down. And if you do the horizontal line test, that will tell you if the inverse of this function is a function or not. Are y'all following me a little bit on that? I got Christine. Okay, there we go. Good, Lucy. Good, Bernice. All right. So now watch this. So this passes the vertical line test. It never hits it more than once. Okay. But does it pass the horizontal line test? Does it pass this horizontal line test? The answer to that is no, it does not. So that tells me this, that the inverse of this graph is not a function. Now, we prove that here. Here is the function. Here is the inverse. Notice here, would this pass the vertical line test? It would not. So that backs up the horizontal line test here. Okay? So if you do a vertical line test, that will tell you whether that function is a function. If you do a horizontal line test on it, that will tell you whether the inverse of the function is a function or not. So vertical line test will tell you whether something's a function or not. Let me rewrite that. Vertical line test. And that's really what I'm trying to get you to get out of this. Is the graph a function? But the horizontal line test, again, just kind of expanding that knowledge of functions here. A horizontal line test is the inverse of a graph, a function. Okay, so now you have that. Now let's go up to like number 3 here. Look at number 3. So here's my question. This right here is g of x. Okay? Go back up to what I wrote. There, Abby. Okay. So, coming back to number 3. Okay. So, this was my g of x. Okay. This is my g of x. Does it pass the vertical line test? Yes or no? Someone type that into the chat box. Yes or no? Does this pass the vertical line test? Yes. Very good, Caitlin. Then my question is this. Does this line pass the horizontal line test? Yes, it does. So that tells me since this passes the vertical line test, it's a function. And since it passes the horizontal line test, that means that this inverse is a what? It is a function. It passes the vertical line test. Okay. That's a lot today, but I trust you guys can handle it. Any questions of me on lesson 5.6 notes? Okay. Give me thumbs up or a smiley face saying that you are good, or you can say I'm good or whatever. Let me know that you're good. Give me smiley face, something like that. Once you've given me a smiley face or I'm good, feel free. You can be dismissed from that. Hey, I'll see you guys. Is it Friday at 11? Someone confirm that for me real quick. Is it Friday at 11? Lucy says yes. Friday at 11. Okay, I'll see you guys Friday at 11 a.m. Okay, hope you have a good rest of your day. Do the homework over 5.6. Do 5.6 homework and then go from there. I'll see you Friday. Any questions over 5.6 homework? And then we'll start the first half of the study guide. Look forward to seeing you guys. If you have any questions, feel free to hang out and ask me in the chat box. I'll stay on for a little bit. Thanks so much. Have a good day, guys. Good day. Good day, Maddie. Good day, Caitlin. Good day, Bernice.
He's done, guys.
Shh. I'm not done yet, Leonard Grace.
Why?
Good day, Kristen. Good day, Christina.
Get that ball.
So, Abby, the +3 on number 5 on the inside of the square root, you would go left 3 since it's on the inside. Abby, I know you didn't do the homework while I was finishing that up because I hope you caught that end part. Did you catch that end part, Abby, about functions and whether the inverse is a function, horizontal, vertical line test? Did you catch that, or were you doing the homework? Oh, okay, I got you. Cool, no worries. Just making sure because you're probably going to see a question on the test about that. Any other questions, guys? What did you say about the V and H line test? You got a question over that, Abby? Yes. You'll probably see a question on your test out that right there. About something to do with the horizontal or vertical line test. Cool.